For years, generative AI has operated under a strict rule of engagement. It speaks only when spoken to. You type a prompt, it generates a response, and then it goes completely dormant. This creates a severe bottleneck. If a machine requires a person to dictate every step, the workflow grinds to a halt the moment you step away. To solve massive problems, an intelligence must work asynchronously, evaluating and executing steps while you sleep. The machine can no longer afford to wait for us. We have reached the physical limit of treating AI as a passive assistant, requiring a transition to systems that direct themselves. Google marked this exact transition by officially declaring their pivot to the Agentic Era. The focus has shifted from generating content to taking independent action. To support this, they deployed a specialized infrastructure, a dual-chip approach utilizing their 8th-generation TPU architecture globally, explicitly built to run their new Gemini 3.5 flash models at extreme speeds. This hardware acts as the engine for a new autonomous cognitive cycle, a machine that perceives its environment, reasons through a problem, and executes an action. To act in the real world, an agent must first understand the physical rules governing it. Text prediction is useless if the AI cannot comprehend three-dimensional space. This requires what Google DeepMind calls a world model. Through their Gemini Omni release, they are training AI to actively simulate reality rather than just fetch data. These systems possess an intuitive grasp of physics. Ask the model to generate a heavy object rolling off a table. It calculates the kinetic energy and applies the exact downward arc of gravity. Mastering simulated physics is the absolute prerequisite. Before we hand an AI the controls to a physical robot in our homes or factories, it must prove it understands how objects collide, fall, and interact. Once an AI accurately perceives its environment, it has to reason. It needs to look at a massive objective, break it down into a sequence of smaller steps, and delegate the work. To test this, Google engineers used their agent-first development platform, Antigravity 2.0, and gave Gemini 3.5 Flash a highly complex prompt: build a working computer operating system entirely from scratch. The AI deconstructed the challenge into a cohesive plan, deploying 93 parallel sub-agents to tackle the architecture simultaneously. Over 12 hours, these agents operated independently, iterating tests, making 15,000 model requests, and processing 2.6 billion tokens. The autonomous team successfully wrote every single line of code, from the memory management to the file system. They built a fully functional operating system, capable of running complex third-party software, proving it could, in fact, run Doom. This exact reasoning logic is already scaling to consumers. Search agents now use agentic coding to build custom, interactive software widgets on the fly to answer complex user queries. Reasoning has moved beyond retrieving documents to autonomously architecting and executing multi-step engineering feats. Which brings us to the final step: execution. An agent can plan a task perfectly, but allowing it to spend our money or interact with our physical lives requires an airtight chain of trust. To solve this, the industry established the Universal Commerce Protocol and a verification system called the Agent Payments Protocol, or AP2. AP2 creates strict, tamper-proof guardrails. Use that precise boundaries for brands and budgets, allowing consumer agents like Gemini Spark to act as authorized financial proxies that purchase goods directly without going rogue. And this action loop is escaping the digital screen entirely. Through partnerships with Warby Parker and Gentle Monster, the technology is entering mainstream retail spaces as intelligent audio eyewear. These glasses continuously monitor your visual field and listen to your context. As you walk down the street, the AI perceives the coffee shop ahead, reasons through your past orders, and acts by purchasing your drink on DoorDash before you even reach the door. The intelligence has moved past the digital container to take active, authorized actions in our physical environments. If a personal agent can autonomously manage your calendar and write software, the next logical step is pointing this exact same loop at humanity's greatest existential threats. Using platforms like WeatherNext and Alpha Earth, agents are actively simulating massive planetary systems to address climate change and food security. In 2025, this system accurately predicted a Category 5 hurricane striking Jamaica a full 3 days earlier than traditional supercomputers could. In biology, Isomorphic Labs is modeling molecular interactions to build virtual cells, creating an environment for automated preclinical drug discovery. This is science moving at digital speed. Compounding autonomous agentic loops are accelerating the pace of discovery well beyond human capability. The era of the passive tool has ended. By giving AI the infrastructure to perceive reality, reason through complex plans, and execute physical actions, we have engineered an active collaborator. Demis Hassabis describes this as the foothills of the singularity, the moment where the independent logic of the system begins to outpace the manual instructions of its creator. As these loops compound, the primary constraint on scientific progress shifts. It becomes less about the machine's capacity to process data and more about the human ability to direct that autonomy toward the world's most complex challenges.